Hi, welcome to Code Along 4, Design in JavaFX. In this Code Along, we will be covering JavaFX shapes and panes, action events and event handlers, the graphic classes versus the logic class, and then how to write a wrapper class. Quick note, after you clone the stencil, make sure to change at the top package Code Along 3 to Code Along 4. You're going to have to do that in all of the files that you're pulling, or otherwise it won't run.
Yeah, and we're gonna leave it as code along 3 because we've opened it on its own and it's fine like this. But if you're having an error where like everything is red or something like that, it might be because your package is still named code along 3. So just go ahead and change that. Also, I'm Janu.
I'm Sean.
We're gonna get started.
So we'll give you a high level kind of design of what this code along is. So we have an app class, the pane organizer class, our top level graphical class, and then the alien class, which here is kind of our top level logic class. And we're going to make a pretty simple program where we create an alien who can move left and right with buttons.
Our alien is going to be a wrapper class. It's going to consist of a few simple JavaFX shapes, one ellipse, and two circles. And the reason we're creating a wrapper class is because it's just a very efficient way to do our design. When it comes to cartoon, you're going to have to create a composite shape that's made up of a bunch of other shapes. If you don't have a wrapper class to handle all that logic, you're going to have to be moving like 5 shapes around the screen all individually, using all of their like X values, Y values, whatever. But by having a wrapper class, we can just focus on doing all of our movement and all of our logic in that wrapper class, and it just like simplifies our design so much. But you'll see that as we like go through our code along today.
Alrighty. So in terms of creating the alien, we haven't actually created the actual JavaScript for you. So you're gonna have to go ahead and create an alien script. Right click on that folder there, new Java class, call it alien.
Oh my God. Alien.
Alrighty. And off the bat, right, we know that our alien, we have to set up its constructor. And because it's going to consist of a few different a few different shapes, we need a way to add these shapes to the pane. So by associating the alien with the pane, we'll be able to add each shape to the pane, which we will show momentarily.
Awesome.
We're going to start off with looking at the app class.
Yeah, so right here in our app class, we have a few things that are going to be in every app class that you create pretty much. So as you can see here, we're creating a new pane organizer. This is our top level graphical class. So this is going to handle all of like the like visually setting up our pane and its many parts. We're going to talk about what is a border pane shortly, but just so that you know right now, we're setting up our new pane organizer. We also create a scene. A scene is going to make sure like the frame or like the class that pops up, the window that pops up when we run our program actually like has a pane organizer in the background, a border pane or just a pane that shows up, which is like basically like the blank canvas that we do all of our design on. And by creating a new scene, that's how we make that happen. We also give our scene an app width and an app height. Yeah, so I'll show you that momentarily as well. But yeah, and then we have to do this one call set scene. We're setting our stage to have a scene, and this all like happens in the background. So don't worry about that, and we'll go over the syntax more in lecture and everything. But yeah, we also give it a title and we make the stage show up.
Yeah, this is exactly how you should go ahead and create your app class following these exact guidelines to create the pane organizer class, the scene, and you'll make the window pop up. So this will be great syntax to follow when you're actually writing your cartoon program. So now that we understand what the app class is doing, we can kind of jump into the pane organizer and start getting it set up. We've provided you with the root pane, right? Which in this case, we want it to be a border pane. And the special thing about a border pane is it has different components to it. And we'll show you that briefly here, if we
In a
can.
brief moment, we will show you this.
But essentially, there's a top, a bottom, left, right, and center, and we can add other panes to those segments of the pane. It's a great top level pane to use, or the root pane. Because of that additional functionality, we can just place panes into the left, right, center, top, and bottom by calling set bottom, set top, set left, etc. So we'll go ahead and change our pane that we have in there to a border pane. I believe when you cloned it, it's just a pane, but it should be a border pane.
Yes, I'm sorry, I think the screen sharing paused. Okay, sweet. So this is the border pane that Sean was talking about.
Yeah, and you can see those left, right, center, bottom, top components that I was talking about, where you can add other panes to the border pane.
Yep. And this is also a great place to talk about why JavaDocs is a really great tool. Anytime you're using anything that you're not sure about, like how to use or like what parameters something takes in or anything like that, and it's a JavaFX tool, you can easily reference that using JavaDocs. So it's talking about what the class is over here and like how to call these methods, set bottom. You have to pass in the node that you're setting to the bottom, et cetera, et cetera. So yeah.
Yeah, JavaDocs, super useful tool. You'll use it in this class and many CS classes to come.
Okay, and now we're gonna go back to our pane organizer. Sweet.
So yeah, so right now it's being initialized as a border pane, but we're referencing it as a pane. We want to change that reference to a border pane so that we can actually call those border pane methods. That was another issue in the stencil code that we need you to fix on your end. So now once that's a border pane, we're going to be able to call those methods like set bottom and set top. And the reason is, remember, declare type. Now that we've declared it as a border pane, we can call those methods. And like we said, we're going to want to have buttons, and those buttons need panes, right? So we're going to start by creating a helper method called setup button pane. And this method, which should be private because we don't want to call it outside of this class, will allow us to set up the pane and then set up the buttons within the pane.
So true. So yeah, so we're doing this as part of our good design, as we talked about always. We want to delegate tasks so that we're not doing everything all in the same class or all in the same like constructor. It would be possible to do this all in the constructor, but it's much more reasonable to create another method to do that. We're gonna create now an HBox or our local border pane, and you're gonna see we're making this a local variable. And the reason we're doing that is because we only really need to call this variable inside this method where we set up the button pane. And instead of taking up memory and like making this an instance variable, making the whole class know about it, we're just doing better design, making it a local variable. So
Yeah.
it's only referenced within this method.
Yeah, exactly. We only need the buttons to know about it, and we can pass it through to the setup button method so that they can add themselves. We don't need the whole class to know about it.
Great.
So once we have that HBox, right, we can set the HBox style, basically setting the color of the pane. This is totally optional, but makes it look nice.
So this just shows also background color, and we're gonna set it to
Number E4CBFF.
thank you. Gorgeous. So yeah, so now this little lovely window pops up and you can actually control your color with that little box on the side there. And yeah, you can call all these methods now on our button pane. And when we run the program, you'll be able to see, but yeah, you can like change the pane that you're creating. Okay, sweet.
So we'll go ahead and run what we have right now.
Awesome. Great. I'm just gonna share screen so you can see what we have. Oh, no.
And nothing has showed up. We don't see the button pane. Why is that? Well, we forgot to add it to the root pane, right? Our root pane is the only thing being added to the scene at the highest level. So in order to get all the other panes and objects to show up, we need to make sure that those panes get added to the root pane, right? So to add to the root pane, right, because it's a border pane, we can call this dot root pane dot set bottom. This handles adding to the pane as well as moving it to the bottom. I know typically in lecture, you're used to seeing get children and add, which also works, but because it's a root pane, it has these nice built-in methods like set bottom, which are going to move the pane to the bottom. And in our case here, we want these buttons to be at the bottom, so we're going to go ahead and set them at the bottom.
Perfect. And yeah, and set bottom takes in a node, and we've created a node, and hbox is a kind of node. It could also be a vbox. It could also be like
another border pane. Any sort of pane would be referenced as a node in this case.
Great. So now it still wouldn't show up because we're never calling setup button pane. You can see this method is still grayed out. So I would go ahead and call this dot setup button pane.
Now, when we run this, you'll see our lovely pane pop up on the bottom.
Interesting. We'll just go back here and run it again. Oh, okay. Did we neglect something?
We called it, we added it, but it's still not showing up.
Debugging. It's a great time to debug. Let's go back to our code and see what went wrong. Pane organizer, get root, return pane, this dot setup button pane, this dot pane.
Maybe it's just because we haven't added any buttons yet.
Okay.
Let's just continue going through.
Right.
And we'll address that issue if it continues to occur. Now we can actually create the buttons, right? In order to create the buttons, we need to create two different button objects, right? A left button and a right button. Oh, yeah, maybe the return type of get root.
Yeah, but that's an aside. We will address it as we come to it. Anyway, what you were saying?
Yeah, so now that we have set up sort of the pane itself, we can actually go to create the buttons in the setup button method, right? So buttons are a JavaFX element, so we can just create them by calling button, maybe left button
equals new button.
And button can take into its constructor a string, which would label the button. So given this is our left button, maybe we'll label it left. And then we'll create another button called right button, which we'll label right.
So you can see these buttons are like coming up red, which means that we haven't imported the class, or like Java right now isn't recognizing this class button. So the thing with JavaFX now that we're using all these tools that already exist is that we're gonna have to import a lot of classes. I'm gonna do this on a Mac by hitting Option Return and then Enter again. And we always have to make sure we're importing the type of button class that's from JavaFX, not java.awt. That will cause a lot of other bugs. So yeah, and you can check that by going to the top where your imports are and just making sure the imports that you're doing are all JavaFX.
Yeah, you never want to have the java.aut.star. That is going to also lead to a bunch of other bugs. So if you ever see that at the top, delete it.
Sweet.
So continuing with setup button pane, there are some other things that we can add to it, but let's go ahead and run it. We haven't actually called setup buttons because it's gray still, but we can call this dot setup buttons from the setup button pane and pass in that button pane, which we created as a local variable.
Setup
buttons. Yep. And then we can pass in that button pane. Now,
awesome.
Now that we've passed that button pane in, we need to add those buttons to the pane, right? We've created the buttons, but they're not going to show up because we haven't added them to the pane yet.
You can see that like we're not referencing this button pane parameter that we're taking in. We're not referencing left button, right button because they're still grayed out.
So we can now do button pane dot get children dot add, and we can add the left button and the right button. So in order to add multiple items, right, we're going to call add all, which allows you to add all sorts of items at once, which is very nice.
Yeah, so what we did just now, just to recap, is we've created these JavaFX elements, two different buttons, but they aren't actually added to our pane. So even though we've created them, they won't be showing up anywhere. But now, like, we're adding them to the same pane that we created up here in setup button pane. So yeah, we're adding them to that pane, which we've already set to the bottom of our screen. We've given it a style, everything like that.
And now we'll go ahead and also, we can set the alignment of the button.
Oh, yes.
So we can run it before we do that. We can just kind of show you what it looks like, before we set the alignment.
Right. Yes,
Yeah.
it's showing up. Hooray.
So it wasn't showing up before because we just didn't have any elements in the pane. Now that we've
Mhm.
added some other components, which were those two buttons, we're now seeing that nice magenta pane at the bottom there.
Awesome. Great, great, great. So now let's do what Sean said earlier. We're gonna set alignment. So this is just something like a visually appealing thing that you can do. And the great thing about cartoon is you have so much creative freedom to do like anything. But yeah, in this case, we're gonna set alignment of our button pane to the center. Because right now our buttons are on the left like side of the pane. We want them to be in the middle. How do you do that? Well, I'm just gonna hover over this and see what argument it's expecting. And the set alignment method is supposed to take in JavaFX geometry pos value. So if I click that, it says, oh, a position is a type of enum. We'll learn what an enum is later, but in the meantime, like when you're doing cartoon, there's gonna be a ton of things that like, sorry, you just don't know like what it is. You might not have come across it before, but you can still totally use it in your cartoon. Just Google and go to like Java docs and like other online resources. Just find out like, oh, how do I use a pos enum for JavaFX?
Mhm.
In this case, you just need to type in the word pos and it's going to come up and give you a ton of suggestions.
Yeah, so in this case, we want to move it to the center. But yeah, like Johnny was saying, Java docs are your best friend going forward because they'll help you explain sort of what those built-in methods do. And you can figure out maybe methods that you didn't realize existed for some existing classes that we've already looked
Gotcha.
at. So then we can also set the spacing between those buttons by using button pane set spacing. So we'll call button pane dot set spacing. And there it takes in a double value, so maybe we'll give it 20. And right now is a good time to mention the idea of constants, right? Going forward, any sort of raw value or string, you want to store that in a constant because one, stylistically, it's more descriptive. When I read set spacing and it says constants dot button spacing,
Mhm.
I know that I'm setting the button spacing to some value as opposed to just 20. So
Let's
that'll,
go do that right now.
yeah, so this will kind of go through how to create the constant, right? All constants should be public, static, final, and then whatever type they are. So double, string, color. You'll run into any sort of type of constant. And also the naming convention is all caps with underscores separating each word. So maybe we call it button spacing, set it equal to 20. And then instead of putting that raw value in, right, we can call this constant. Similarly to how we did app width and height in the app class, we can do it here in the pane organizer. So constants dot button spacing.
So this is just another instance variable, like we're just creating an instance variable in the constants class, but we're setting it to public. The only instance variables you're ever going to set to public are in your constants class, because you want to be calling on these variables from other classes, so you make them constant. And the whole point of constant variables are that you want to change them in this class, but like call on them in other classes. We never do that with any other variable, but right here we're calling constants.button spacing. We're going to do that for other things. So this is another like super long string. Why do we have that when we could just have like a neat constant that's telling me like what to do there? Another thing is in your constants class, you should always have comments talking about like what each constant, like each block of constants is doing. So all the constants down here are going to be for our alien, but I'm going to add another constant here, public, static, final, string. So that's the type that Sean mentioned. And it's just going to be background color. and it's just going to be the string that, oh, not that string, but the string right here. Great. And now instead of calling this super long string, I can just say constants dot background color. So your constants don't just have to be numbers or doubles, and doubles are just like a type of, they're not an integer, but they can be decimals, things like that.
Yeah, and now we're gonna go ahead and run it and see what this new style has. Boom.
Beautiful.
So you'll see here. Now we have the left and right buttons centered, but you'll notice there's this blue outline whenever we click on the left or right button, and even when we move it with our keyboard. So this is called set focus traversal, and it's affected by keyboard input, but also when you are clicking on the buttons. When it's highlighted blue, it has focus on that. So when you press spacebar, it'll press the button. And we don't want this to happen, right? We only want to press the buttons like when we're actually
literally
pressing
clicking it.
them with, yeah, with our pointer or our mouse, right? So we can do something like called set focus traversable, which is a method in all these JavaFX elements, and we can say set focus traversable false in order to prevent this focus from happening, because that may cause us to press the button when we're not intending to. So for example, if we had a class which had a quit button, if set focus traversable was never set to false on that, and we are moving our keyboard and we hit space and it's on the quit button, it's going to quit our game, and we don't want that to happen. So by setting focus traversable on all these buttons that we don't ever want keyboard interaction with, that'll help prevent it. So just a good thing to note whenever you're, employing buttons or other things that you don't want keyboard to input to affect.
So there could be times when you do want your focus traversable to be true, like when you're creating a game that uses keyboard presses, like potentially Doodle Jump potentially in the future. But for now, we want to only make our buttons like interactable when we are like clicking on them with our mouse. So, and also we're putting all this in here because your setup buttons method knows about your right and left button as well as your button pane. We could also put this line about the button pane setting traversable to false up here where we set up the button pane, but I'm just putting it down here so that they're all together. Just a choice. And your setup buttons knows about your button pane because you're passing it in.
And so we're going to go ahead and add some functionality to these buttons, right? Now they press, but they're not doing anything. So what we can do is we can use a lambda expression to give these buttons some functionality here. So, right, in the actual setup buttons method, right, where we have our buttons, we can do button dot, and for the left button and the right button, so like left button dot set on action. Set on action takes in event handler, so action event E. So we're creating an action event. We're saving it to a local variable E. This dash and then caret is to signal a lambda expression, and then maybe we'll do like system dot exit or system dot exit 0 with a capital S.
Yes.
Right, and this is kind of just showing you how the lambda expression should be written. This is going to be good syntax for adding functionality to buttons, maybe in your cartoon or in future projects when you just want any sort of functionality out of a key press or button.
Yeah. Perfect.
So now if we run the code, right, we have supposedly added a set on action to our left button. So now the system should exit when we press that button. Let's give it a shot here.
1 second.
And we'll share the screen with you here so you can see that. Left.
We click left.
And
Excellent.
yay.
Awesome.
Alrighty.
Great.
So now that we have our buttons, right, obviously we need to now implement our alien class. So like we mentioned earlier, our alien is going to be a wrapper class of composite shapes, right? So we're gonna have an ellipse to represent the alien's head and two circles to represent their eyes. So
will this be an instance variable or a local variable? In this case, we want it to be an instance variable. And the
Mhm.
reason for that is that everywhere in this alien class, we need to know about the head and the eyes of the alien. All the movement that's going to happen for the alien, everything like that. The whole point of the wrapper class is that we're moving all of our objects together, or any action that impacts like the whole figure, like the whole composite shape, needs to happen in your alien class. So we're going to make instance variables because we want like the same head to be moving. We don't want to be making them locally. Right, so it's still gonna be private though, because this is the only class that needs to know about this. And yeah, we're gonna do an ellipse. I'm gonna just call that head. And you can see here, again, more stuff to import, which is honestly kind of fun. And then you have your private circle, eye. So obviously, like we already planned this, like we knew what our alien was gonna look like before we started this code along, but maybe you're experimenting and you're like trying to figure out all kinds of polygons. I1 maybe one.
we'll call left and right eye maybe
Oh,
just to
yeah.
keep consistent with the.
Yes, with good style and design. Also, like if you weren't sure, like how would I make a circle, you would use JavaDocs for all that.
Yeah. Yeah, looking at the Java docs for a circle or an ellipse will let you know sort of what the constructor takes in, all the different methods they have available to each other. So like we did in the pane organizer class, right? We don't want to write all this setup logic in the alien constructor. Instead, we want to delegate to a helper method. So maybe we'll create a private helper method like make alien. And again, this is private because we're not calling it outside of the alien class, right? We're never going to create another alien like shapes outside of the alien class, right? This is something we only ever want to call when we create an alien. And here we'll initialize the head and the left and right eye. But as we mentioned earlier, we need some way of adding these to the pane, right? And through association, letting the alien know about the pane, we'll be able to easily add all these components to the pane, which we'll illustrate shortly. But let's start by setting up the head and the left and right eye. So
Awesome.
head right is an ellipse, so we'll create a new ellipse.
Right when you like when you knew a class that already exists and you hover over it, it will tell you like what arguments this like class is expecting. So for the ellipse, we could give it a radius and a radius X and Y, but in this case, I think we want to give it a center, like a location, a center X, center Y, and a radius. All right.
Exactly. Yeah. So you could just create a blank ellipse and that would run perfectly, but
Mhm.
obviously we want to specify. We want to put it in the middle of the screen and we want to choose its size.
Mhm.
So we'll put it at X equal to 150, Y 100, and then the radius 50, 70.
Wait, but Sean, we have all these numbers here. Shouldn't we be making it constant?
Exactly, Johnny. So we should move these raw values into constants. So, right, again, public static final, their type, which in these cases are all doubles. We'll maybe do like alien X, alien Y, right, to represent the X and Y position.
150. And we're just gonna copy this over for the Y, and which
Change it
is
to 100.
100.
Bang. And then obviously we had a radius X and a radius Y, so we'll label those appropriately. 50, and then the radius Y. Which we have at 70.
Orange. Awesome.
Now we can use those constants in place of those raw values.
So, and these will come up right when you start typing because hopefully everyone set up their code completion in lab 4, but if you haven't, definitely reference lab 4 on how to do that because that will be a lifesaver. Okay, radius X and our
And then
radius
finally,
Y.
radius Y.
Great.
Now, obviously, we need to continue initializing the left and the right eye as well,
So
right?
true. So now we have our left eye, which is a new circle.
And a circle, right? We can look at its constructor if we hover over it. So in our case, we're going to want a center X, center Y, and a radius. So we'll go into our constants class again and set those values. So we'll go public static final, and we'll create I X offset. And immediate question is probably, what is X offset? Why isn't we doing just IX? And that's because our eyes depend on the location of the head, right? So if per se we wanted to move where the alien spawned to the left side of the screen, if we have the eyes as an offset of the X and the Y coordinate as an offset of the alien Y, every time we move the alien's location, the eyes will move accordingly. So it's great practice if you can to make your composite shapes sort of kind of locations depend on each other. That way, changing one will change all the others, as opposed to doing the calculation manually.
Yeah, and imagine like since we have two eyes, instead of going back like into our alien class and like changing the number for each eye, what if our alien had 7 eyes or something?
Mhm.
We would have to go in and change that offset for each eye every time we notice some kind of error. But now if I just set like I'm just gonna add the other variables before, but um if we want to change our like constants or we want to change some number, we can just go do that right in the constants class. And it will save us like a lot of time in the long run.
And then obviously too, we want our alien to move, so we're gonna create a move offset.
Oh, yes, yes. And this will come in handy later, but we're just gonna do that right now. Final, and it's also a double move offset. And how much is that?
That is 10.
Okay,
And then,
share alien.
so now when we create these eyes, right, the X position, right, we're gonna call them the alien's X position. And then because it's the left eye, right, and remember in JavaFX, 0, 0 is the top left part of the screen. So in order to go left, right, we subtract to go left and we add to go right, and then we subtract to go up and add to go down. So the Y direction is kind of counterintuitive, but X is what you're used to in, normal coordinates.
Yeah. Another nice thing about like visual debugging with this kind of project is like even if you completely forgot what Sean just said and you just do whatever you're thinking, like, oh, left is usually minus, right is usually plus, like if you're looking at a normal like graph. When you run your code, you're obviously gonna like visually see that your objects are like in the wrong place and it'll be easy to visually debug. But it's worth remembering, like Sean just said, your top left corner is 0, 0.
Exactly. So now like we said, we're going to determine the position of the X based on the aliens. So we're taking whatever alien's constant X value is that we're setting the alien to, and then we're going to subtract our offset from it. In other words, moving it left by 10, because that's what we decided our alien offset would be. Right. And we could do something similar for the Y, but in this case, we're just setting Y to a fixed value. But we could also make our Y position with a Y offset. So we could do like constants dot alien Y and do some sort of subtraction or addition with the Y offset. But again, just for simplicity here, we're just going to set it to a fixed value because we're only moving left and right, and because it's just easier based off the solutions.
So, what was the third thing? Oh, the radius, the eye's radius. Sweet. Okay, and we're gonna do the same thing for the right eye.
And we'll just copy and paste that down just to make it a little easier.
So
But
it's
instead, this time adding X offset, and we'll actually, I'll show you what the Y offset would look like. Because right now, right, we have constants, just a fixed value. But if we wanted it to depend on the alien, like we do the Y, we could do alien Y, and then it's because it's eyes, it's usually a little bit taller on the face. Maybe we'll subtract by some offset, right? Right now it's just alien IY, but if I go back, I can make this into an offset like we did with the Y. Maybe make it 10. So now
Nice.
it's going to take whatever the alien's Y position is and go up 10. So now we can do that. Same for the right eye. Now, in this case, right, if we just change the spawn location of our alien head, it'll automatically adjust the eyes because they depend on the alien's head location.
Yeah, and that when you're moving like a composite shape, instead of moving like each, in this case, we're gonna show you how to move each element, but you can also just like, just think about it as like, oh, the location of the eyes are gonna depend on the location of the head. You can't just have the eyes be wherever they want because when you move the head, you need the eyes to move with it.
Well, this is more of just on creation, though.
Yes,
Just
yes.
on creation. But when we move, right, it's all
Yeah.
about getting each object's current location, right? So
Right.
we could set these equal to just some fixed value, but it's just easier to use an offset because now whenever I want to change the spawn location of the alien, all I have to do is change these and the rest of it.
Awesome move.
Exactly.
Yes. Okay, so true, so true. Okay, so let's just see how it looks now, right?
Yeah. But we haven't created an alien, so it's not going to show up,
It's not
right?
showing up on the pane.
So let's go back to our pane organizer class and see if we can create another helper method, right? Because like we've created helper methods for setting up the buttons and the button panes, we need to set up our alien in a similar way here.
Okay.
So we'll obviously make this private because we don't need to call it outside of the pane organizer. Make alien. And because our buttons are in a different method and we want our buttons to call methods on the alien, we're going to make our alien an instance variable here. So like similarly in your top level logic class, when you're creating objects and you want them to move or have some sort of a functionality, you're going to make it an instance variable because it's a component of that like logic or that game, whatever you're creating. So then you can call its methods. So, right, we now have an alien called myAlien, and then in this alien method, we'll set up that alien by calling the constructor, new alien. But we need a way to add the alien to the pane. How can we do that, John?
Well, maybe Sean, we can pass in a pane.
Yes, so we can create a local pane variable, right? Just a regular pane.
And we're just gonna, and this is gonna be a pane as opposed to a border pane. Because we just need it to show up as a pane.
Yeah, we don't need the sections of it. We're just looking to add the alien to its own canvas. One thing to note though is that like when you should separate objects into their own panes, objects that don't need to or like are not associated, not necessarily associated, I misspoke. Just objects that
Are
are
like,
separate objects should be in their own panes because that's good design and will prevent weird interactions. Like if you were to shove everything into one pane, things were overlapping and you might not get the functionality you're looking for.
yeah, and always think about like delegating and like what needs to interact with what. If you have two different composite shapes and they're not interacting at all, it might make the most sense to just separate them into two different panes. But yeah. Okay, so now we need our alien to know about this alien pane so that it can show up on that alien pane. We also need to figure out a way to add our alien pane to our root pane. But yeah,
Exactly. So like we can call set center in the same way we called set bottom earlier, and set the alien pane in the center.
of our root pane. So remember, we don't need to do this whole like get children, add children thing because our root pane is actually a border pane and we can just use these methods that exist. So alien pane.
We may need to take a brief pause to plug in here.
Yes, so let's do that right now. I will pause the recording. We're back. Okay, so yeah, so what we did last was we set our root pane to like we set our alien pane to the center of our root pane. We want it to be like right in the middle when we have our like pane that we created at the very beginning. Okay, but now our alien needs to know about this alien pane so that it can
add itself and add all the components to it. So we'll give the constructor of the alien a pane called pane. We could call it my pane. We could call it the pane, whatever you want to call it, right? So now the alien constructor takes in an object of type pane. We're getting one related problem because it's expecting us to pass in the pane here, but we didn't give it anything. We'll give it the alien pane that we just created. So now we can actually add the alien to the pane. So if we go back to our alien class here, and we call our make alien, right? This is where we're setting up our individual shapes. So in order for these shapes to then get added to this pane, we need to pass the pane to the make alien method, right?
right. So again, like this is just a name right here. It's just an arbitrary name. It can be anything. This does not have to necessarily match this, but the type that this is taking in, the make alien method, has to match the type of pane we're passing in here.
Yes, because we're like any parameter passing, a double, a integer, that you just need to match the type of the object that you're passing it to. So we're passing a pane to this pane here, and now in the make alien method, we can say my pane dot get children dot add and add the head and the left and right eye.
Right. So so now like we can reference this variable that we've given right here in anywhere in this method. And now, like Sean just said, we're gonna add all our nodes.
Yeah, so a good thing to note here too is that the order in which you add things to a pane and the order in which you create panes will determine the layering of your program. So, right, if we were to add the eyes and then the head would just be on top of the eyes and we wouldn't be able to see them, right? So it might make more sense to just add the objects as we create them, right? So we're going to add the head here because we want it to make sure it goes in first. And then after we create the eye and the left eye and the right eye, we'll add it to the pane.
And it doesn't matter what order we do that because they're not overlapping. The right eye and the left eye.
Correct. Alrighty, now we'll go ahead and run that. Oh no.
It's not showing up, but I think potentially that's an issue with our pane organizer because I don't think we ever actually called the
Make alien.
make alien method.
Classic. You're going to run into a lot of those errors where you expect it to work. You felt like you put it all together and then nothing shows up. Just go back to the basics. Make sure that you call everything. Make sure everything is yay, but it's
Oh, we didn't set the color.
alrighty. So we can go back
I
to
think they all do in fact exist. We just need to
they're
set
all the same color, so they're mixing
Yes.
together. So all shapes have this nice set fill method. So we can call it this dot head dot set fill and pass in a color. So color dot, the same way we did pause dot, we
And-
can do color dot.
and it already gives us some great suggestions. Just remember you want to pick the JavaFX like suggestion.
So color dot green.
Let's
And
go
now,
back and run this.
yeah.
Yay. Gorgeous. Okay.
Now we need to make our alien move left and right.
Yes.
Naturally, we need methods to call move left and move right on our alien. That's what's so nice about this composite shape class, right? Is now that we have a class which contains all the different shapes, we can write one singular method which handles moving all those shapes at once. So we don't have to call individual move methods on each shape.
Like, could you imagine if you had a composite shape like that had like maybe hundreds of like individual circles or something? I don't know. It would be a nightmare to have to move all those individually. But yeah, so we're just gonna make a move left method. And again, this is why we made our head and our eyes instance variables because we need our move left method to know about them.
Yeah, and you could make one singular move method and have like a parameter like is left like you had with those paddles in the past, right?
Yes, in Pong.
And so it would like move left if true or move right if false. Or we could just create a move left and a move right method. Either is up to you. Just a design decision.
Yeah.
Write about it in your README, whichever one you decide to use.
And we're just gonna
But-
do a move left and move right, just so, like you can see like the nice appealing visual difference.
And the question, do we make these private? No, because we're gonna call on them in the pane organizer, right?
So true.
So now we want these methods to be public because we want the buttons to be able to call them, as opposed to make alien, which is just something we call once when it's
Mhm.
created. So in order to move objects, right, we're really just setting their position to their current position plus or minus some value and
Yeah.
doing that repeatedly, basically incrementing it left a few or right a few. So
The other nice thing about Java FX is that there's these built-in getters and setters.
Mhm.
So instead of having to like make your own getter methods or setter methods, you don't have to do that. They're already existing. It depends on what shape you're using for sure. Like I don't think rectangles have quite the same like
yeah, it's going to depend per shape, and I would read the Java docs to see, the different methods that each shape has. You might find, oh, this shape has more and even easier methods to use. So you definitely use the Java docs to your advantage because they're so helpful.
But yeah, so we want to change the center X of the head whenever we're moving it. And how do we do that? Well, we want to make sure we're getting the current X that it is and then offsetting that by some value.
So when we move left, and remember our coordinates here, moving left is subtracting x by 1, right? Because if we're in the center of the screen and we want to go towards 0, we're going to slowly but surely subtract from that current value.
Nice. And what are we going to subtract? We're going to subtract our constant. Because what if like once we start using this, we're like, oh, it's kind of moving a little too slowly. Like I want it to move by more each time. Instead of going through like all of our move methods, we can just change our move offset in our constants class.
Again, a beautiful thing about those constants.
Awesome. Okay, so now we have our left eye and our right eye that we also have to change, right?
Yes, so we'll do, again, set center x, and this time get the left eye's coordinate, and then, again, offset it by that same value.
Yes. We're gonna offset it by the same value.
And then we can just copy and paste that for the right eye.
Yes, yes, we can.
It's a beautiful thing about composite shapes.
What?
You get to just copy and paste code once you do it for one shape.
Yes, so true, Sean. Okay.
Make sure we change that inner, yeah, to the right eye. You would have caught that though if we were visually debugging.
Yes.
All right, same thing for move right, except instead of subtracting, right, we're adding.
Great. Beautiful, beautiful thing about composite shapes. We just have to change the sign. Again, visual debugging would be really great here. If you just had mixed up those signs, you'd be able to see them. Great.
All righty. Now let's go ahead and call these methods, right? Before we had left button call system exit, but this time we can have it call move left. Same thing for the right button.
So this is also why we had our alien be an instance variable. Like you can see it's grayed out here, it's not being used. If at the end of your program you have some grayed out instance variables, they're just not being used. They're being there just takes up space. So go
Yeah,
through there and
because
get rid
currently
of
we
those.
only are using it in this one method. So Java's like, oh, maybe we could make this a local variable, but as
Yep.
soon as we go to reference it in this other method, it's gonna go pink and realize that we are using it as an instance variable.
Yeah, so now we want our aliens to move left every time we hit that left button. Same thing we want to do for our right. So you can see like we have our set on action, we have our lambda event, and we're just saying every time I hit my, oops, sorry, this is right button. Every time I hit my right button, I want to move right. And you can also do this like set on key pressed if you're moving, if you're hitting like your left, right arrow key, whatever. Same idea. Okay,
And now we'll go ahead
sorry.
and run that.
Yes. Awesome.
All right. Yeah. Move
Yay!
left, move right.
Awesome.
And like we mentioned, if you want to speed this up, all you have to do is change that constant value and your movement changes. Um, and we want to now briefly mention timelines, sort of a way that we can get rid of buttons, but still include movement and action. And timeline is gonna what allow you to make like animation. So you can make something move back and forth across the screen with a timeline because every instance of the timeline you'd call move right, move right, move right until the alien gets to the side of the screen, in which case you want to now call move left, move left, move left. And therefore you can make the alien kind of bounce left and right on the screen. So there's tons of different implementations of a timeline, like a score or a counter.
Or like animating your composite shape, like we just talked about.
Yeah. So you'll have to use that in cartoon.
Mhm.
But we just kind of wanted to introduce it to you guys and understand sort of just the many uses a timeline has.
Yeah. The last thing about a timeline is that so like just talking about our program here, like we talked about, we have our app that like sets up our stage and our scene and everything. We have our pane organizer, which is our top level graphical class. It handles all of our graphics of creating different panes and like arranging them together, setting them to locations, whatever. Visually making our alien show up because our pane class is associated with our alien. But our timeline wouldn't go in any of these classes. It would go in its own in a different, like a top level logical class because our timeline is not doing anything to like visually make something show up. Like our pane organizer sets up all of that, but our timeline handles the logic of like what happens when over time or whatever, or like what happens when 60 seconds pass and you want your counter to stop. So all that logic happens in a different class, potentially maybe a game class or something.
Yeah, a great example would be like um, a game that has a timer and your
Like
timers in your game
like
class.
flow free. Do you know what I'm talking about?
Yes, 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 flow free,
Yes.
where you have a timer and
You're trying to make the little maze happen in 60 seconds. And if the 60 seconds run out, like you need to stop the
yeah,
game.
great implementation of a timeline.
Thank you, Sean. Okay.
Alrighty, thanks for watching Code Along 4. Hope this
Yes.
video helped.
Thank you. Bye. Ah,
Let's go.
killed that. Oh, still recording.